Okay, this one is about the oxidation state. We talk about the oxidation first, like oxidation and reduction. Oxidation is gain electron, lose electron. Sorry, gain oxygen, lose electron, and then we have learned about the oxidation state lah. So oxidation number increase. We also consider it as oxidation. Reduction is loss oxygen, gain electron, and oxidation number decrease. So for example, this one, okay, for example, this one, oxygen gas become oxide, okay, become oxide. So oxygen in element form, it is the oxidation state is zero. So when okay, oxygen become oxide, why? Because it receive electron, because it receive electron, okay, and then it become 2 minus. Okay, so from 0 to minus 2. So oxidation number decreases. So it is reduction. It is a reduction. Huh? Okay. So you see this one? Okay, this diagram. So a rise in oxidation number means oxidation has occurred. A fall in oxidation number means reduction has occurred. So let's say, for example, okay, from 0 to plus 2. So this one is oxidation. From 0 to plus 4, it is oxidation. It is not necessarily everything must start from 0. Maybe from plus 1 to plus 2. This one is also oxidation. Okay, from plus 3 to plus 4. This one is also oxidation. So as long as it goes to the right, it is oxidation. What about the reduction? Reduction, for example, from 0 to negative 2. Let's say, for example, chlorine become chloride, it receives electron. Okay, or oxygen become oxide, it receives 2 electron. Or, okay, like what I say, from negative 1 to negative 2, it is also reduction. From negative 1 to negative 3, it is also reduction. Okay. Then we go to example for this one. Okay, this write a word equation. This one very simple lah. This H2 is hydrogen, O2 is oxygen. Hydrogen plus oxygen become water lah. Okay. Now copy out the chemical equation and write the oxidation state of the number. So this one just copy paste here. I don't want to write here lah. Huh? Okay, we move a little bit. More, make it more space so that we can write clearer. So you see this hydrogen and oxygen. Okay, this hydrogen and oxygen, they are neutral. They have no charge. They are not in the form of compound. So they are zero. Oxidation state is zero. You don't care about the number for balancing 2 or 1 or what or this how many atoms. You just look at the element itself alone. This one oxygen also zero because it's neutral. But when it becomes this so-called compound, okay, H2O is a compound because different element. So you see this H, this H now is actually what? Okay, in ionic form, H is H plus. Then oxygen is what? Oxygen is O2 minus, receive 2 electron. So H now is plus 1. O now is minus 2, negative 2. Okay, now let us see which one is oxidation. So hydrogen to hydrogen, let's look at hydrogen first. Hydrogen, from 0 to plus 1. From 0 to plus 1. So 0 to plus, so it is to the right. The oxidation number increases. So this is oxidation. Oxidation. And oxygen from 0, this is not all, from 0 to negative 2, it reduces, it drops, the number drops, the oxidation number drops, so it is reduction. Okay, So this is very simple. So I clear all and we go to the next questions. Is this a redox reaction? Yes, because it involves reduction and oxidation. Okay. So this one we already discussed. So we look at these two examples. We look at these two examples. Make it more spacious. Too much. Okay. So you see, this one a little bit terbalik. This one is a compound. Compound become element. This potassium bromide. Potassium is in group 1. So potassium is in group 1. Bromide is in group 7. So potassium in group 1, how to become stable, it have to give up 1 electron. Bromide in bromide it is in group 7, so it receives 1 electron to become stable. So the oxidation state for potassium is +1. The oxidation state for bromide is -1. Okay, then they are separated, they become element. So this potassium become what? Potassium is an element, it's not in a compound form anymore, so it's 0. So bromine, Br2, don't care about the 2, because they share electron. This one bromine atom and one bromine atom, they share electron. So it is also 0. Now very obvious already. So one is oxidation, another one is reduction. So you see potassium from +1 to 0, +1 to 0, like to the left or to the right. Or you can ask yourself, if the oxidation number increase or decrease. So from +1 to 0 means to the left, means it is reduced. So it is reduction. Okay. So bromide from -1 to 0, from -1 to 0. Okay. So it increases. So it's oxidation. Okay, come to the last example, potassium iodide plus chlorine gas become potassium chloride plus iodine. Okay, this chemical equation, actually is very simple. Chlorine is more reactive, so it tend to react and combine with potassium compared to iodine. So this simply saying is chlorine kick up iodine and combine with chlorine. No? Okay, so iodine is kick up, 被踢出去. Okay, so this potassium, what is the oxidation state? The oxidation state is +1. Okay, iodine -1. Okay, we finish all. Chlorine 0. Iodine also 0. And potassium in a compound form +1, always +1. Metal become ion. Metal become ion is always positive charge, positive ion. Non-metal, when they become ion, it is always negative charge. Always negative charge, remember. Okay, so now we analyze one by one. We analyze one by one. I think use the red color. Okay, potassium. You see potassium, we look at the element one by one. Start from potassium, then iodine, then chlorine. So potassium +1. On the right hand side, also +1. No change. There is no change for potassium. So this one we leave it there. What about iodine? Iodine is -1 now. -1. And then on the right hand side, is 0. So iodine from -1 becomes 0. Okay, so this one is oxidation. Oxidation. Chlorine is 0 become -1, 0 become -1. Okay, so it is reducing, or the number is reducing, so it is reduction, number is reducing. Okay, so all these involve oxidation and reduction, so they are called redox reaction. Redox, this one also redox. So yesterday we have discussed about neutralization, right? The acid plus alkaline. No redox reaction because the oxidation state from the beginning until the end from the reactant to products are the same one. The oxidation state all are the same, no change. So that neutralization is not redox reaction. Okay, thank you.